Hello and welcome students. This is our lecture number 3. In this lecture, we are going to discuss a new topic which is resolution of more than two concurrent forces. In the last lecture, you have remembered that we have discussed about the numericals of law of parallelogram of forces. But what is the limitation of the law of parallelogram of forces? Actually, in the law of parallelogram of forces, we can find the resultant of only two concurrent forces, P and Q. Then there will be a resultant R on the diagonal of the parallelogram. But actually, in practical situation, there are number of loads, number of point loads are intersecting at a single point, means number of loads are concurrent at a single point. Then it is difficult to find the resultant with the help of law of parallelogram of forces. So in this condition, when lots of forces are applied on a single point, then we have to change the method. So now we are discussing the next method, resolution of more than two concurrent forces. So in this method, we will see how the resultant can be found out when number of forces are more than two. You can see in this figure that what is given to you. Consider P1, P2, P3, P4. Four forces, etc. are acting at a point shown in the figure. This is the figure in which origin is the concurrent point. From the origin, the number of forces acting are P1, the second one is P2, the third one is P3, and the fourth one is P4. Remember that all the forces are making angles. Angles are with respect to horizontal axis only. You can see the first angle is theta 1, second angle is theta 2, third angle is theta 3, and the fourth angle is theta 4. These four are the forces, are the angles of respective four forces with respect to horizontal axis only. So you have to remember that whenever the forces are coming into the picture, the angles must be with respect to horizontal axis only. Okay. Now you have to find out three values, sigma h, sigma v, and r. Now what is sigma h actually? Sigma h is equal to algebraic sum of horizontal forces. Now in the figure, all the four forces are not horizontal or vertical, but we have to make components for these four forces. You may remember in the physics that the horizontal component is known as cos theta and vertical component of the force is known as sin theta. So sigma h will be equal to algebraic sum of all horizontal components, while sigma v will be summation of algebraic summation of all the vertical forces, and r equal to resultant of all the forces. Okay, so these are the values which we have to find. The formula to find out the resultant is under root of sigma h square plus sigma v square, in which sigma h and sigma v which we have find out earlier. Now what is tan theta? Actually theta is the direction of the resultant, and to find out the theta, the formula is tan theta equal to mode of sigma v upon sigma h. Mode means positive value. Sometimes what happens, sigma v and sigma h, either of the two can be negative. So to make the angle positive, we have to take mode of the value. By doing tan inverse, we can find out theta, which will give the direction of the resultant. Now theta equal to angle of resultant with horizontal. Here four cases with respect to four different quadrants is given to you. If sigma h equal to positive and sigma v also equal to positive, then it is the first quadrant. Resultant will be in the first quadrant. You must remember this. You can see in this figure also. If the horizontal is also positive and the vertical is also positive, then the quadrant is first quadrant. Right? Now similarly, if sigma h equal to negative, sigma v equal to positive, then the resultant will be in the second quadrant. If both are negative, then the resultant will be in the third quadrant, like this, in the third quadrant. If sigma h equal to positive and sigma v equal to negative, then the resultant will be in the fourth quadrant. You are very clear to this. Four number of quadrants are there for positive and negative value of sigma h and sigma v respectively. So you have to practice this basic fundamentals. So let us go ahead. We will start some numericals and we will find out some angles, some resultants, sigma h and sigma v, and finally we will locate the resultant like this, like in the last figure. So let us start with the numerical number 1. Before that, we just discussed the condition of equilibrium of coplanar concurrent forces. Now, what is the condition of equilibrium? A system of coplanar concurrent forces is said to be in equilibrium if the following conditions are satisfied. First of all, what is equilibrium? If number of forces are acting on a particle, then also there is no effect on the particle or the particle is not moving. Okay, so that condition is known as condition of equilibrium. For that, three conditions should be satisfied. First one is sigma h equal to 0. So algebraic sum of all the horizontal components must be 0. All the horizontal forces summation must be 0. Second one is similarly sigma v equal to 0. Means algebraic sum of all the vertical forces must be equal to 0. And third one is sigma h equal to 0, sigma v equal to 0. So accordingly, earlier formula, which is r equal to under root of sigma h square plus sigma v square, that is also becoming 0. So now r also must be equal to 0. So these three conditions should be satisfied to make the system in equilibrium. Sigma h equal to 0, sigma v equal to 0 and r equal to 0. We will discuss all these cases in the numericals, turn by turn. Let us see. Let us start with the example number 1. This is the example based on resolution of more than two concurrent forces. Let us see example number 1. What is given in the data? Determine magnitude and direction of the resultant force. What we have to find? Magnitude and direction means r and theta. Okay, you can also say r and alpha. Of the force system shown in figure. This example has been asked in GTU September 2009 exam. This is very basic numerical. Now, remember and listen to me very carefully. There are number of forces. First force is 100 Newton, second one is 120 Newton, third one is 130 Newton, fourth one is 50 Newton, and the fifth one is 100 Newton. You can check in the figure that out of 5 forces, 4 forces are tensile. What do you mean by tensile force? The force coming outward from the origin. So from the origin, all the forces are coming outward. Only this force, 50 Newton force, is coming inside. Okay, is coming inside to the origin. So that force is known as compressive force. So this will be the compressive force. Okay, so this compressive force is not allowed. So first of all, we have to convert this figure into tensile forces. So you can see in this figure that this is the first force, tensile as it is, second force, tensile as it is, third force, tensile as it is. But now what happens? This 50 Newton force is coming from left, so it will be going into the right direction like this. So you can see this is 50 Newton force. Okay, hope you are clear to this. So 50 Newton force is going to the right direction, and the 100 Newton last fifth force is tensile as it is. Now looking towards the angle. So what is given in the angle that this angle is 60 degree. So this angle is 60 degree as it is. Lower angle is 60 degree. So lower angle is 60 degree as it is. But now 120 is on y-axis. So it is making 90 degree with the x-axis like this. But now you can see for the 130 Newton force, the slope is given to you. What is slope? Slope is like this, 12 by 5. You can remember from the mathematics, 12 by 5. So this angle will be theta. This inside angle, inside the triangle is theta, which can be found out with the help of tan theta. What is tan theta? Opposite upon adjacent. So opposite of this theta is 12. You can see 12. And the adjacent side is 5. So tan theta is equal to 12 by 5 written over here. With the help of calci, it will answer 2.4. And if you do tan inverse of the value, you will get the theta equal to 67.38 degree. So this is our theta in the simplified figure. This theta will be 67.38 degree. Correct? So this right side figure is the simplified figure for our calculation. Now we have to calculate sigma h and sigma v from this calculation. Now please concentrate how to find sigma h and sigma v. Let us discuss that. See the same figure over here. Now we are concentrating on the simplified figure only for the right figure. Correct? Now starting from the x-axis, positive x-axis only. First of all, we are finding sigma h. Then after we will find sigma v, and then we will discuss later. First force is 50. Okay, so it is making 0 angle with x-axis, right? So first value is 50 cos 0. The second angle with the force of 100 Newton is 60 degree with x-axis. So all the angles should be measured with positive x-axis only, not from y-axis, not from any other forces. Always start from the x-axis again and again. So second force is 100 Newton, the angle is 60 degree, so the value is 100 cos 60. Why the sign plus in between any two values? Because it is sigma h. Sigma means what? A summation. So while doing the summation, all the values should be added and added. Okay. So the third force is 120 Newton. But this 120 Newton is also making angle with x-axis only. So from the x-axis, it is making 90 degree like this. So it will be 120 cos 90, the third value. Fourth force is 130 Newton. You can see the 130 Newton force. This force is making an angle theta with left x-axis, negative x-axis, which is calculated earlier 67.38 degree, correct? But we are interested into finding out the value of this angle, 130 Newton force angle from the x-axis only, this angle. So this angle will be 180 minus theta, correct? You are getting this linear pair, 180 minus theta. So it will be 112.62. So final fourth value will be 130 cos 112.62. Plus the last force is 100 Newton. Let us change the color so that you are not confused. For this 100 Newton force, again angle will be required from the positive x-axis only. So this angle, this total angle will be theta for the last force. So 180, 270, and this gap is 30. You can imagine this is 30 because the upper angle is 60. So total you can find out like this also. This total angle will be 360 and subtracting reverse 60, so it will give you 300. So 100 cos 300 is the final angle. Correct? 100 cos 300 is the final value. So this is sigma h. Now just keep your calci with you. Replace all these values in your calci and just simplify this equation and you will get the answer of 100 Newton. So sigma h equal to 100 Newton, which is right side. Right side means positive. So answer is positive in your calculator. So this is basically sigma h. This method will be repeated again and again. Remember one thing, again I am repeating. First of all the compressive forces should be converted into tensile forces. Then after find sigma h. While finding the sigma h, all the forces should be making angle with positive x-axis only again and again. Sigma means addition in between the quantities. Now what is sigma v? The same values, all the values of sigma h, all these values should be copied over here like this. You can see these are the copied down values like this. Okay, only the difference is that in place of cos we have to replace sine because it is sigma v vertical component, so sine components. Forces remains as it is, angles remains as it is, no change. So just replace sine in place of cos and again solve in your calculator. You will find out sigma v 240 Newton. Now the term resultant. Now what is resultant? Under root of sigma h square plus sigma v square. Sigma h equal to 100 Newton, sigma v equal to 240 Newton. So just replace the values, you will get the answer of 260 Newton. So this is the magnitude of the resultant, 260 Newton. Now the time for the direction of the resultant. What is the direction? Tan theta equal to mode of sigma v by sigma h. Sigma v is 240, sigma h is 100. So answer is 2.40. If you do tan inverse in your calci, you will get the answer of 67.38 degree. Here you can see that sigma h is positive and sigma v is also positive. So both are positive. So resultant will be in the first quadrant. So you can locate the resultant like this in the final figure. This is x-axis. Okay. This is y-axis. Now both are positive. So horizontal is positive like this. Vertical is also positive like this. So resultant will be going in the first quadrant. So draw the resultant in the first quadrant like this. Make the value r equal to 260 Newton, which we have calculated in this. And the angle must be with positive x-axis only. This angle means direction of the resultant theta is equal to 67.38, which should be written over here while locating the resultant. So this is the final basic numerical. What is first? First of all, convert the compressive forces into tensile forces. What is step number 2? Find out sigma h. While finding the sigma h, all the angles must be with respect to positive x-axis only. Third step, find sigma v. Sigma h should be copied in sigma v. Only the change is that sine is replaced in place of cos. Solve your values in the calc, you will find sigma h and sigma v. Then after you have to find resultant force R equal to under root of sigma h square plus sigma v square. And then direction of the resultant theta. And then we have to locate the value of the resultant. Okay, so this is the basic numerical. Let us see one more numerical to understand the funda very well. What is given in the data? A system of 4 forces shown in figure has resultant 50 Newton. What is change? Here the resultant is already given to us, which is 50 Newton along positive x-axis. So you can see in the figure that along positive x-axis the resultant is 50 Newton. So remember this thing, when resultant is already given in the numerical and it is along the sigma h, means along the horizontal axis, then R is equal to sigma h and sigma v will become 0. Why? Because the total effect of the resultant is along x-axis as given in the data. So vertical effect will be 0. So sigma v equal to 0 and sigma h is equal to directly a resultant, which is 50 Newton given to you. So our work is very easy now. What we have to find? Determine the magnitude and inclination of the unknown force P. You can see in the figure, this is the unknown force P and the angle which is unknown, which is theta. So we have to find P and we have to find theta. The forces are 100 Newton, 200 Newton, 150 Newton and P. There are 4 forces. Okay, let us start with the sigma h. The same method. First force is 150 starting from this axis. Angle will be 0. So it is 150 cos 0. The second force is P and the angle will be theta. So it is P cos theta. The third force is 100 Newton as you can see. But the angle will be this 30 plus 90, so 120, so 100 cos 120. This last force is 200 and the angle is 180 plus 60, 240. So 200 cos 240. So the answer will be 50. So this is sigma h. So sigma h will become 50 now. Now by solving this calc, you will find that P cos theta is the only unknown term. So you can find out the equation like this. P cos theta is equal to 50. Make this equation as number 1. Now the same figure we will calculate for sigma v. Let us see the calculation of sigma v now. The same figure is here. Now sigma v, the same values are copied. First one is 150 sine 0. But sine 0 actually equal to 0. So 150 sine 0 is neglected. The second force is P and the angle is theta, so it is P sine theta. Next one is 100 sine 120, so 100 sine 120. Next one is 200 sine 240, so 200 sine 240, but sigma v equal to 0 now. So the unknown term is P sine theta, and in your calc you will find the equation number 2 like this. P sine theta equal to 86.26. This is equation number 2. What we have to find? P and theta. Okay. Now we are dividing the equation 2 by equation 1. So this is the division of equation 2 and 1. So what is given in the equation? P sin theta upon P cos theta. So P will be cancelled out. Sin upon cos means tan theta. And this division will give you tan theta equal to 1.732. By doing tan inverse, you will find theta equal to 60 degree. So our first answer is completed. Theta is equal to 60 degree. Just replace this theta in this equation number 2. P sin theta equal to 86.6. So by replacing the value of theta equal to 60 and solving in your calc and dividing 0.866, you will get the answer of P equal to 100 Newton. So this is basically the numerical number 2. In the first numerical, all the forces, all the angles are given to you and you have to find the resultant and you have to locate the resultant. While in the second numerical, resultant is already given to you, but you have to find inclined force P and the unknown angle theta. So these two are the variety of numericals for the more than 2 concurrent forces acting at origin. Okay, so this is our method number 2. We will discuss number of examples in the next lectures, number of difficult numericals in the upcoming lectures. Till then, students, very goodbye, and make sure that you are referring all the videos carefully. Thank you.